In this video lesson, we're going to find out how we can use the heats of formation for both the reactants and the products to determine the heat of the overall reaction. So right now we're going to recap some of the ways that we can calculate the heat of a reaction. So some of these we've discussed already. We can calculate the heats of a reaction in a variety of ways. So one, using calorimetry. So calculating the temperature change throughout a chemical reaction. And we can also use Hess's law. And then finally, we can use the standard enthalpies of formation. So these use the formation reactions where compounds are made from their individual elements. And there's a lovely table that we can consult to determine these heats of formation. So a standard enthalpy of formation is the quantity of energy that's released or absorbed when 1 mole of the substance is formed from its elements in their standard states. And we can find the delta H for a reaction by using the standard enthalpy of reaction for each of the reactants and their products. Now, there are a few rules that we need to follow. The first rule is that the delta H of formation is delta HF. It's the standard enthalpy of formation, so at standard state. The other rule, for elements in their standard states, the delta heat of formation is 0. The delta H of reaction is found using the following equation. So the sum of the delta heat of formation of the products minus the sum of the delta heat of formation for the reactants. And when summing the delta heat of formation values, they must be multiplied first by the coefficients from the balanced chemical equation. We also have to be aware of the states because they must match. So when you're looking up the delta H of formation, make sure that you're looking up the correct state. So like, gaseous water vapor versus liquid water vapor. Now we're going to try an example. So our example says, using heats of formation, calculate the delta H for the combustion of ethane. Express the answer in kilojoules of ethane. So the very first thing that we need to do is find the balanced chemical equation. So we pop that in here. This isn't balanced. Now we need to balance it. We want to keep this as 1 mole to make our calculations easier. So we're going to use fractions in our balanced chemical equation just to keep things simplified. So the first thing we can take a look at, we have 6 hydrogens here, but only 2 over here. So we need to put a 3 here. So now we have 6 hydrogens, 3 oxygens here, and we have to balance our carbons now. So we have 2 on the reactant side, so we need to put a 2 here. So that now makes a total of 4 oxygens plus 3, that's 7 over 2 to balance that out because we have 2 oxygen atoms over on this side. So this is our balanced chemical equation. These values will come in handy a little bit later. So our next task is to find the heats of formation for each product and reactant. So there's a variety of different tables that are available to us. So I've inserted one here for us to consult. So the first thing we need to do is find the heat of formation for ethane, so C2H6. We look that up on the table. And where is that? C2H6, so ethane is right here. So our standard heat of formation is negative 84.68. So we'll draw that in. Kilojoules per mole. Now our second one, we need to find the heat of formation for oxygen. But remember, oxygen is an element, so it's going to be 0 kilojoules per mole. It's an element, and they're 0. You don't have to form them, they're already formed, they're an element. Our next one, we need to find out the delta heat of formation of CO2. So we look that one up, and it is negative 393.5 kilojoules per mole. And then our final one, our heat of formation for water, remember we need to be mindful of the state, so it's gaseous water. And it is, right down there on the bottom, negative 241.8 kilojoules per mole. So those are our delta H of formations for all of those. So now we're going to calculate the enthalpy of reaction. So remember, that's equal to the sum of the number of moles times each of the heat of the products minus the sum of the moles times each of the heat of formation of the reactants. So we'll put those values in. So that's equal to N delta H formation of water plus N delta H of formation of the next one of CO2 minus the N delta H of formation of C2H6. And remember, we don't have to worry about oxygen because it is an element that has an enthalpy of 0. So that's equal to 2 times 393.5 kilojoules per mole plus 3 times negative 241.8 kilojoules per mole. And that's all in brackets. We're going to subtract the formation of the reactants. And that's equal to 1 times negative 84.68 kilojoules per mole for ethane. So that's equal to negative 787 kilojoules per mole minus 725.4 kilojoules per mole minus 84, so plus 84.68 kilojoules per mole. So that's equal to negative 12.4 kilojoules per mole plus 84.68 kilojoules per mole. We'll add that. That's equal to negative 1427.72 kilojoules per mole. And that's how you find the enthalpy of reaction using the heats of formation of the products and the reactants.